All right. Good morning to you. Glad we're all here?
No.
And not too gassed from the stuff?
No.
All right. So we're in 5.6. Let's dive right in. I'm going to dive right in hopes that we can get through this. So we're in a financial. Did you guys finish up 5.6 okay?
No, halfway. I'll go back and finish it.
Challenging section, huh? Long section, isn't it? All right. Well, this section, it's all about, we're going to have two main formulas. Here comes the first one. It's a financial section. It's all about like investing money and compound interest and all that kind of stuff. So there's the first of the two formulas we're going to use. A equals P parenthesis 1 plus R over N to the NT. A is the amount at the end. P is the principal at the start. R is the interest rate. And T is the time in years. T is time in years. And N is the trickiest part. It's the number of compoundings per year. So if they say like semi-annually, then that's N equals 2. That's twice a year. Semi-annual means twice a year. If they just say annual, that's just once a year. If they say like quarterly, compounded quarterly, how many times a year is quarterly?
4.
4, so N would be 4. If they say monthly,
12.
N is 12 times a year. If they say daily,
365.
365. We'll ignore leap year. Yeah, so those are the different things they will say as we use that formula. All right. So let's do it. So then we take this. You guys have your calculators with you? So the amount will be P. What's the principal?
The main amount that you start with.
It's the 600, right? It's the 600. And what's the R? What's the interest rate? 0.09. 9%. You always move the decimal 2 places, right? 0.09, make it a decimal. What's the N, which is number of compoundings per year in this problem? Quarterly, 4. To the N again, ends up in the power as well. T, what's T? 4 years. So there's what we need to type into our calculator. Let's just hit the buttons at this point. I think it's easiest to go ahead and figure out that power ahead of time. 4 times 4 is 16. And so what I'll type into my calculator then will be 600. They're all a little different, but probably it's something like this on your calculator. Plus 0.09 divided by 4 to the power 16 equals. Something like that. Oh, I didn't bring mine. I should have. Let me grab mine. Did y'all get a number on that one? 600. Oops. To the power. I'm getting 856.57. 856.57. $856. So now 600 will grow to become $856.57 after 4 years at 9% compounded quarterly. Make sense?
Not the nearest cent.
Yeah, they want the nearest penny. So 856.50. If you can read that there, I'll write it up here. 856.57. is the amount. Good on that? Questions I can answer on that one? If you have trouble with your calculator, if somehow it's not working, grab me after. Just take 10 seconds probably. Help you with that. All right, there we go. So same formula. A is P1 plus R over N to the NT. Try that one. $200. Put it in the bank at 3%. Compounded daily, 4 years. What's it going to become? Principal's 200. The rate is 0.03. N, what's N on this one?
365.
Yeah, daily. The N is number of compoundings per year, 365 and 365. And time is again 4 years on this one. So I like to figure out that power first. 65 times 4 is 1460. So typing that into your calculator. $225, and I'm getting 498, so that would round to 50, huh? 225.50? Is that coming out okay? That good? Questions on that? All right. I'll move along. All right. Okay, try that one. $40, invested 12%, compounding continuously, 4 years. What's in?
365.
I know it's probably the best guess, huh? But continuous is even more than once a day, isn't it?
Oh, like every second?
It's even more than once every second.
Infinite.
Continuous means nonstop, right?
Is there another formula for that?
There you go. So I want you to see that we'd rather me to say, now we need another formula. I think it'd stick with you better if you tried it and saw the normal formula is not going to work. So when they say continuous, you need to use a new formula. It's called, I call it the Pert Formula. A equals PE to the RT. That's for continuous. You need to use the E for when they compound continuously. So when they compound continuously, you got to have a different formula because that's different kind of compounding. So we got to use the Pert Formula. So the rest is the same now, once you recognize that. So they'll do that all the time. They'll be trading back and forth. Whenever they say continuous compounding, you always use the Pert Formula. That's the other formula instead of the first one we were using. Okay, the rest is the same. What's the P?
40.
It's the $40. The E is just E. R is 0.12. It's actually a little easier formula to use. T is 4. So again, I like to figure out the power ahead of time, and that's 0.48. So on your calculator, that'd be 40 e to the power. You have an E button, which is usually above natural log, second natural log. You have an E button, 0.48 equals. I'm getting 64.64. $64.64. So $40 will become $64.64. Is that good? So continuous compounding, different formula. So those are the two formulas you're going to want to put in your 3x5 card for the test, at least regarding this section. All right. Stop me if you. So, yeah. So first off, which of the two formulas are we going to use on this one? Is the compounding continuous or not? It's not continuous, it's just monthly. What's in for monthly?
12.
12. So we're just going to use the normal formula, the one that has the in, right? So it's going to be A equals P, the first formula we used, R over N to the NT. Good so far? Like that?
So our amount
We use the
would be-
PERT for continuous compounding, right? Yeah, now, so we're using the first formula, but something's different. You see what's different?
We have the final amount.
Yeah, the 300 is actually the A, isn't it? It's not the P's. Everybody's hit 300 is not the principal being put into the bank. It's the amount you want to get eventually. Yeah, the amount you want out. Yeah, to get 300, right? Remember the A, if I go back to the original thing here, the A is the amount at the end. The principal is the amount you first put in at the start, huh? So therefore, the 300 is the A. We don't know the P. That's what they're asking us for. Find the principal, right? The rest is the same. The interest rate is 0.11. The N is 12, as we said. This is 12 times 3, which is 36 power. So there's the little, plugged everything in. How do we solve that for P? P's not alone yet. Well, we could just divide by this whole chunk that's next to P to get P alone, right? Just divide by the whole 1 plus 0.11 over 12 to the 36 power, and it'll just cancel that whole thing out. Whatever you do to one side, no choice, but to do the same thing to the other to keep the balance. So P's alone, it equals 300 over that whole big thing, huh?
Now we just play that in my calculator.
Yeah, let me give you a way to make that real convenient. So 300 over 1 plus 0.11 over 12 to the third. So we're to there. Good so far. Now, what's a nice? You could type it all in. It's a little tricky, not too bad, but here's something that'll make it a little easier. It's easier to start with the messy part. Just do that first, and then use that answer button, A and S button. Have you used that before? To finish it off. So here's what I mean. So just start with the messy part. 1 plus 0.11 divided by 12 to the power 36. Hit equals. Okay, so then you'll have that answer on your screen. Here, I'll do it too. So 1 plus 0.11 divided by 12 to the power 36. I'm getting 1.3888, something like that. Okay, then go 300 divided by answer. You know the answer button? You know where that is in your at least on the TIs, it's lower right-hand corner. Hit second and whatever that is, and you get the answer. It's different places, different calculators. It's very convenient button. It just makes it easy to type things in. And I'm getting, 216.00. $216 exactly. Is that good? Yeah.
Should we have used like
Luis.
LN on both sides? To bring down the
Good question. Yeah, LN does bring down powers, that's true, but we really only want that when the letter's up in the power. That's when we have to get that power down, when the letter has climbed into power. We just had number up there. So it's not that it's wrong, but it's overkill, it's not needed. We can just divide both sides on that. But yeah, when letters get into power, that's when we have to do LN. Good?
I'm not.
Alex?
I keep getting 1 for the bottom.
1 for the bottom. 1 plus 0.11 over 12 to 36, huh? Yeah. Maybe I'll try checking a little bit. Yeah, so come grab me after if something weird's happening on your head, because they're all a little different, so I have to do that individually. Come grab me. So 216 is the amount that should be put in the bank now that'll become 300 in 3 years. Good on that? You guys okay with the divide and the answer button and all that? All right. Yeah, try that one. To get 5,000 after 2.5 years. Let me see, Alex. Go ahead and type in what you did before, and I'll look at it. Oh, you must be in a mode where it automatically rounds stuff off. That's weird. Here, let me watch. one was in the parentheses. The whole thing? Yeah. No, just put 11 over. Put it for, yeah, 11 over 12, yeah. Two, right. Yeah. There you go. Yeah. All right, so now this is another one. Which formula are we using on this one? The first one, huh? Because it's not continuous compounding, is it? It's not continuous compounding. So to get 5,000, 5,000 is the amount. And the interest rate is 6%, 0.06. Compounded daily, what's daily? 365 for n. To the nt, 365 again, and times t. T is 3.5, 3.5 years. So I'm just going to figure out what, I always do the power first. Just makes it easier for typing in later. This is 1277.5. So now to solve for p, we just divide both sides by 1 plus 0.06 over 365 to the 1277.5. 1 plus 0.06, 365, 1277.5. And so that's a big mess. 1 plus so I'm getting 4052.
Yep. 0.99.
0.99. So that's the amount you got to put in the bank. Does that make sense? You guys getting that okay? So you got to put $4,052 in the bank, or 53 basically, to become 5,000 in 3.
Would you have done this by hand before?
By hand?
Yeah.
Before when?
Well, your time.
Back when the covered wagons were still moving?
Not messed up.
No, I was in the calculator generation. I was, I don't know anything about slide rules. No, I had calculators. Yeah. I'm not that old now, Rule. I'm fairly old. I graduated high school in '85, so I'm a bit old. But, yeah, we had calculators. Is that good on that? Isn't that kind of amazing? It goes up almost $1,000. What'd you do for that $1,000?
Nothing.
Just left it in the bank. Or whatever the investment was, just left it. That was only 6%, right? Einstein called compound interest the seventh wonder of the world because of that kind of a surprising thing.
As a side note, Bitcoin is worth $5,000 per Bitcoin now.
Wait, what's that?
Bitcoin.
Okay.
It's at $5,000.
Okay.
Started trading at like at 8 cents.
Okay.
5-6 years ago.
Wow. That's some growth, huh? Okay, so effective rate. Yeah. Well, let me give the idea first. What do we mean effective rate? Did you know listed rates are not exactly the same as effective rates? So, for example, if somebody says 10%
Bless you.
compounded annually, that just means once a year, then that's the effective rate is 10%. And this is the listed rate. So if it's listed at 10%, the effective rate is 10%. But if they say 10% compounded semi-annually, that means twice a year, right? You know, N is 2. You'll actually, the effect will be, it'll be a little bit higher than 10%. It'll go up to 10.25, will be the actual effect at the end of the year. If you compound money more frequently, it actually makes it grow slightly higher than the listed rate. If you do 10% and you compound it daily, that'd be 365. Then, I don't remember, what would that be? How do I do that? 1 plus 0.10 divided by 365 to the 365. Yeah, that would be 10.52%. Even better. If you, and on you can go. So basically, the more frequently you compound, the effect is actually making a little higher than what's listed. Does that make sense? Truth in lending laws now require that they put this kind of thing on. If you buy a house, buy a car, they have to put down the actual effect so they're not fooling anybody. So they'll say, blah, 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 10% compounded, however, But the real, if they compound more than once a year, see this one up here was just once, annually is just once, well then yeah, the effect is the same as the list. If you only compound once, then 10% is 10%. But if you compound twice, it already jumps up to 10.25. If you go up to daily, it goes up even higher. I mean, not dramatically, it doesn't go up to like 20% or something, but you know, it goes up a little bit. So that's the effective rate. That's the real effect on your money. If you put a bunch of money in, or if you take a loan, after 1 year, you really will have to pay or gain that amount. That's the actual effect. That's what will really happen. Now, how do we figure that out? How am I coming up with those numbers? Well, to find effective rate, I think the easiest way, I say that because Math Excel does a different way. If you click to show me an example, they'll do something that I think is a little bit crazy, a little hard. Just use lots of formulas and stuff. It's not that hard. All you have to do for effective rate, let me write a note here. For effective rate, and this is probably something you're going to want to put in your 3x5 card. For effective rate, let t equal 1 year and p equal $1. And then take your answer and subtract the original $1 and then change your decimal back to percentage. So there's the game plan for effective rate. At least my game plan
Back
for
to
effective
what?
rate. Back to percentage.
That,
So I think it'll make sense as we go. So let me get this out of the way. Yeah, I'll show you. So basically, whenever to figure this out, if somebody's asking you to find the real effect of a certain percentage setup, then what you need to do is, so first off, we're going to use the same two formulas we've been using all along. No new formulas here. Just if they say continuous, I use the PERT. If they don't say continuous, I use the first formula we use. So what this one says compound quarterly, so it's not continuous. So I'm just going to use the first one we were doing, R over N to the NT. If they say continuous, that's when we always use the PERT one, right? The PE to the RT. All right, so they're not saying continuous, so it's just the first formula. And now, how do I do it? What do I do? Well, here's the thinking. Let me give you my thought why I use this method. If you want to know what if I told you, hey guys, I put $1. I had some investment scheme thing, and I put in $1, and that dollar became $1.05 after 1 year. That $1 became $1.05 after a year. So how much did my money go up by?
0.05.
Yeah, right. What would I need to do? You take that answer, subtract the 1, you get 0.05, change it to percentage, 5% growth. That's all I'm saying you do at the end, right? If you can find out what happens to $1, well, then you can find out what's happening to every dollar. You can find out what's happening to the account. Does that make sense? If I told you $1 became $1.05, I could just subtract out that original dollar of mine and get the growth. The 0.05 is the growth, and then just change that to a percentage. The money grew by 5%. That's what I'm saying at the end. Subtract your original dollar, change it back to a percentage. And you'll know the effect of that type of investment, the real, actual effect in the end of 1 year. That's why it's t equals 1 year. Because we always want to know in 1 year, what's the effect, what's the annual effect. Okay, so that's the game plan, that's the thinking behind it, if that helps. Put in $1, just find out what happens to $1 after 1 year, you'll know what happens to every dollar. So here we go. So, and they do that whenever they say effective rate. So P is $1. The interest rate, 5.25. How do you make that a decimal? 5.25. And again, that's just the listed rate. The real effect will be a little higher than that. It'll be a little higher because we're not just compounding once a year, we're compounding what? 4 times a year. So it'll be a little higher than 5.25. I don't know, 5.3, 5.28, 5.31. I don't know, something a little higher than 5.25 will be the real effect on our money. So the rate, listed rate, whoops, gotta make that a decimal, huh? 0.05. I almost just wrote 5.25. Got to make it a decimal. Got to move this back 2 places. 0.0525 over n. N is 4, and what's t? 1 year, because we're doing $1 for 1 year, trying to find the effect on $1 after 1 year. So then just hit the buttons on your calculator. and I get 1.053542, blah, blah, blah. Anyway, so what are we supposed to do with that answer now?
And this one.
Because that's what happened to the $1 we put in, right? The $1 became $1 in this. So we're looking for the growth. What did it grow by? Well, subtract out your original dollar. It grew by 0.053542. Change that back, that's a decimal, huh? Change that back into percentage, move it 2 places. So the growth was 5 point, how many places about? Oh, 3 decimal places. 5.354%. So the listed rate was 5.25, the actual effect was 5.354. A little better, because it was compounded 4 times a year instead of just once. Make sense? How you figure effective rate? Click on the Show Me an Example button. They have a really hard method with all kinds of different formulas.
Ignore.
Yeah, don't do that. I first discovered it when my son took this course a few years ago from me, and he just kind of used the Show Me an Example buttons and figured stuff out. And then I gave him the test, and I graded the test, and I graded the effective rate question. So there you go. There is an effective rate question on the test. And he did all this crazy stuff all over the page. I was like, Daniel, what is this? What is all this crazy stuff here? He's like, well, Dad, that's what they showed. I'm like, what? So I went on the thing, and sure enough, they had a wacko method. So just $1, 1 year. That's all you need. That finds the effect.
The Harry.
All right, so try that one. So the effective rate is 7%. So again, effective rate. So $1, P is $1, T is 1 year, right? So put in $1 1 year. Which of the 2 formulas are we going to use?
The PE one.
Yeah, the
Pert.
PERT one, right? Continuous, because the compounding is continuous. So use the PERT one. Use the Pert formula. And when you get your answer, subtract out the original dollar and change the decimal back to percent. So $1, the listed rate is 0.07, the time is 1 year. So the listed rate is 7%. We're expecting the real effect to be higher than 7, right? Like 7.2%, 7.138, or I don't know. Something a little higher than 7% to be the real effect. Because we're compounding continuously. So it's going to go higher. Maybe it's 7.2 something, I don't know. All right, so what do we get? So e to the power 0.07. We get 1.072508. And so that's what $1 becomes, right? $1 became $1 and some change. So what did it grow by? We'll subtract the original dollar out. So it grew by 0.072508. Change that decimal back to a percentage, move it 2 places. 7.251. They went 3 places? Yeah. 7.251%. So that's the actual effect of a listed 7% continuous. 7% continuous really makes your money grow by 7.251 every year. That's what will really happen to every dollar every year. Make sense? It's the effect. All right. So whenever they compare a couple of investment schemes, like 7% quarterly or 7 1/4 annually, how you compare them, like which one's really going to have a bigger effect? They say would yield, effect. Which one's really, so it's an effective rate question, really, is what it is. So that's how you compare 2 different interest rates. You just say, well, let me put $1 for 1 year into the first one and $1 for 1 year into the second one and see which one becomes more. Right? And if you find out what happens to $1, you know what happens to every dollar. Right? So I could just take this first one, quarterly, so that's P 1 plus r over n to the nt. Put in $1, p is $1. Interest rate is, listed interest rate is 0.07. N, number of compoundings, 4, right, quarterly. N is 4. This one annually is n equals 1, huh? To the n is 4. What's the time? 1 year, because we're always doing $1 for 1 year. So hit the buttons on your calculator. Because I already got it. You guys are quick. I'm getting, 1.071859. So subtract out the original dollar. The growth is 0.071859. Change, move it 2 places. 7.186%. On that one, how about the other one? If you take this one, notice it's only once per year. So it's the same as its listed rate. You don't even need to do the formula. You could if you want to. Nothing, it won't change at all. If you did the work, it would come out the same. So n equals 1 effective is the same as listed. If you're only compounding once a year, that is the rate. Boom, done once a year.
Yeah.
So it's 7.25%. You could do the Pert formula if you want, but it'll come out exactly the same. So which one's better?
The second one.
Yeah, the 7.25 is still higher. So the other one grew. The 7% grew, but it didn't grow enough. It only grew up to 7.18. So that's not better than 7.25. Make sense? On that, effective rate helps you compare apples with apples. Okay, so what rate of interest compounded annually is required to double in 18 years? Double in 18 years. Well, how are we going to do that? Well, first off, it's going to be one of those two. The whole section is those two formulas, basically, are everything. So which of the two formulas are we going to use? The first one or the Pert one? Compounded, does that say continuous? No, it's annually, so we're just using the first one, right? So you only use the Pert one for continuous compounding, right? So just using the first one. All right, they're asking what rate of interest, I got to find the R, to double. What does that mean to double? Times 2, huh? Yeah, what's times 2?
The investment.
The amount is double.
2A.
I'm making a mistake, but I want you to try to figure out what that mistake is. What's the N? Annually. For annually, what's in? 1, just 1, huh? Just once a year. What's the time? 18 years, right? T is 18. So that right there, well, here, you'll see why it's a mistake. I mean, it's a real small mistake, but a lot of students make it. That's why I'm doing it, so you'll see. A lot of students do that right there. That's so close to right, but it'll cause a problem. Like, what are we supposed to solve for? What are they even asking me for in this problem?
What rate of
Right.
interest?
Yeah, what rate, huh? What rate? They want R. They're asking me what R is. So I got to solve for this R right here, don't I? Yeah. So how do I solve for R? Well, the problem is I've also got P. We can't have two letters with only one. If you have two letters, you need two equations. If you've only got one equation, you can't have two letters. It's going to mess me up. I'm like stuck, and this is what happens to students on the exam. They'll get to here, and they'll just, they won't know what to do with the P, and something's bad. So what's wrong? What am I doing wrong?
The amount,
Yeah, what should the amount be?
2 times, 2x. I thought the amount will be 2p.
2P. Because it's double the principal.
Oh, yeah.
Isn't that what it means for something to double? The amount becomes double your principal. Double whatever you first put in. Does that make sense on that? Let me say something goofy just to help it, because so many people make, I try to think up weird things to say for mistakes tons of people make. Lots of people, lots and lots of this. So what if, just think this way for a second. If you just put a 2 there and not a P, you know what that would be like? That'd be like if I said to you all of a sudden, hey, double. You guys would think, double what? Wouldn't you? Exactly. There's no such thing as double without something, right? Double something. So there's no such thing as a 2 floating alone. You got to have something with it, right? So it's double P. Double the principal. Now, why is that so helpful for solving? Because then what's my first step?
You can divide by P.
Yeah, boom, it's out of there and it's not troubling us anymore, huh? Yeah. So really it would have been fine if you just made the A2 and the P1, or just no P at all. That'd work too, and that's totally fine with me, I don't care. Either way's good. So where are we at? There's still going to be a little bit of work though. So once we got through that, now r over 1, that's just r, huh? And that's just 18. We good to there so far?
Yep.
Okay, now this is still a stinker of a problem. This is pretty tough. How do we solve that? We're trying to solve for r, right? R saying I want to be alone. What do we do? Yeah, we could do ln. I mean, but we mainly do ln when the letter's in the power zone. When the letter. I mean, so you could do it. It'd be kind of overkill. Yeah, in a minute we will have that though. In a minute we'll be solving for t, and t will be up in the power zone, and I'll totally do ln. That'll be exactly right. So the ln is for dethroning when the letter climbs into power, right? So I'm not going to do ln here. But I do need to get rid of that 18. How can I get rid of that 18? Raise both sides to the 118. Because that'll multiply and cancel it, huh? 2 to the 1/18th is 1 plus r. Kind of weird thing. We're not or the 18th root, same effect. The 1/18th power is the 18th root. Same thing, either way you want to do it. Yeah. And then subtract 1. So it'll be 2 to the 1/18th minus 1. You type that in on your calculator. You know how to do that? Like 2 to the power 1 divided by 18 minus 1. Let's see what we get. 2 to the power 1 divided by 18. I'm getting 0.03. How many places do they want here? 2 decimal places. 0.03. Oh, but they want me to convert it to percentage. 0.03925. So, and then that's a decimal. So can move that 2 places because you got to make it. See how they want percentage in the end? So move it 2 places, right? It's always 2 jumps. 3.925%. That rounds to 3.93, huh? There it is, 3.93%. In other words, that's the interest rate you need to make that thing happen, make the money double. 3.93, basically 4%, just under 4% on that. Is that good on that? Questions on that one? Investment people talk about the rule of 72. You ever heard of that? No. I can't spend too long on this, but real quick. I always want to put in other side things, but there's hardly time. We have so much math to do. Rule of 72, basically for doubling money. Investment people, if you talk to any investment person, they'll talk about that. Well, that means if you have any two numbers that multiply to be 72, those two will double your money. So, for example, 9 times 8 is 72, right? Or also 4 times 18, which is the 2 we just saw, 18, and that's basically 4. What that means is if you invest money at 9% for 8 years, or vice versa, 9 years at 8%, it'll about double your money. Or 4% for 18 years, that's what we found, right? 18 years, 4%, it'll double your money. Any two numbers that multiply to be 72, if one of those is a percentage and the other is the years, that'll real close to double your money. It's called the rule of 72. Actually, Gauss came up with it. Triple rule. So try that one. What rate of compounded annually required to triple?
So would it be 3P?
Right.
Okay. 3P plus P.
So which formula are we going to use? The first one or the Pert one? The first one, huh? Because it's compounded annually. It's not continuous. We only use the Pert one for continuous. So use the first one. And the triple means 3P, right? 3 times the principal, 3 times whatever was original. And the rate, that's what they're asking for, so that's just R. The N is 1 and 26 years. Hey, what's your guess? Isn't 3 times 26 72? No, it's not. 78, huh?
It's not 70.
18, 6, 7. It's close. So the answer is going to be a little lower than 3. See what I mean? Because a number just below 3 times 26 is 72. It's the rule of 72. So just below 3. I'm guessing the answer is 2.8, 2.9, something like that. So first step, divide by P. Oh, no, that's the doubling rule. This is tripling. Never mind. I'm getting confused. That was the rule for doubling your money. This is tripling. This is a different story. So I don't know what the answer. I have no idea. I'll just solve it. So 3 equals 1 plus r to the 26. You all good to there? I'm racing ahead of you. So what do you do now? Can you finish from there? Can you solve for r there? So r saying I want to be alone, so you got to get rid of that 26. So you raise both sides to the 126 or 26th root. Same thing, huh? So cancels. So 3 to the 126 is 1 plus r. Then just subtract the 1. So 3 to the 126 minus 1. So 3 to the power of. Make sure you're cranking these in your calculator because it's not always as easy as it looks. 0.043159.7. So what are we supposed to do? Move the decimal 2 places. 4.3, and they want 2 decimals, so 4.32%. That's the interest rate needed to do that. Yeah, so it's higher because you got to triple it, not just double the money. It's like, that's surprising though. You can triple your money by just investing at 4.3. That's not a high. You can get that. You can get that kind of rate currently in investments pretty easily. I mean, that's a low rate.
Bank or at a stock?
No, not banks. No, but yeah, bonds and stocks and stuff like that. Yeah, but you can mutual funds. You can triple your money, but of course you got to wait a while, don't you? 26 years. That's like college fund, retirement fund, triple your money. So I don't know how to do that off the top of my head. What's that? What interest? They're talking effective, and they're saying compound semi-annually. Okay, so compound semi-annually. Which formula am I going to use? The first one or the PERT one? PERT is only for continuous compounding. So this would be the first one again. We haven't done many of the PERT ones. I keep choosing the other ones. Anyway, okay, so we use that one. And it's a little tricky. So, okay, effective. What I always told you to do for effective rate is put in t equals 1 year, p equals $1, right? So let's do that. $1, and time is going to be 1 year. Semi-annually, what's that mean for n? 2 times a year. Semi-annually is twice a year. R is what we're looking for. Okay, we good to there so far. Is that okay so far? Right, so time is 1 year, because that's what we always do for effective rate, right? $1 1 year. P is $1. So $1 1 year. The N is 2, because it's semi-annual. Okay, now, what does it mean if your effective rate is 6%? What does that mean about the amount you get after 1 year? What $1 becomes in 1 year? 1.06, right? Does that make sense? If you're growing, if the effect, the actual result of this investment plan is 6% growth, then $1 in 1 year will become 1.06. So that's what we put in for A. Does that make sense? How I figured that out? It's got to be 1.06. Now we can solve for R. So they're telling me effective rate is 6%. So that means 1.06 is the amount that'll come out. So it's not just 0.06. But it's 1.0, right? $1 will grow to become an amount 1.06. Good on that. And so now we solve. So this is 1.06. This is 1. That's not a 0.1. It's just 1. Plus r over 2 to the 2. So how should we solve for r there?
Turn that to 1 over 2, right?
Do a half power on both sides, right? Yeah, is that what you're saying? Yeah. Half power on both sides. Half power like that. Half power, because it's kind of like we're peeling an onion. We're going to work from the outside in, right? We're just going to get rid of that 2. We're going to get rid of that 1, and then get rid of that 2 underneath in. We're just going to, like peeling an onion. Outer layer, final inner layer. Just working our way on down to the R. Trying to get the R alone, right? So get rid of the outer layer, half power on both sides. So that's 1.06 to the half power. The other side is 1 plus r over 2. We got rid of the outer layer. Now move this 1 to the other side. 1.0. I'll do the decimal later. I'm just going to leave it like that for now. R over 2. Last step to get r alone there. Multiply the whole side, both sides, by 2. Boom. So there it is. Hit the buttons on your calculator. I would probably, just to make it quick and easy, do the complex part first. I would not start with the 2. You can, it's okay. But you gotta do lots of parentheses and be all careful about it. You can just start with the inside, -1 equals answer times 2. Or just times 2, it'll pop up answer automatically. These nice calculators these days. So, half power, that's a root, but you can just do 0.5 power, it'll work. I'm getting 0.059126. And they want a percentage, 2 places, percentage. 5.91%. We're out of time. We didn't quite finish 5.7. No.